So yeah, let's implement a script. We will basically run a script without set-e, and let's see what happens. In this case, let's just go and create another script called vi. So like let's say script without set dot sh, and we can insert mode, and let's say echo. Let's just set up like step 1, create a directory, something like that. Let's just try mkdir. Okay, in this case, since I don't have this specific location, let's say this would fail. Okay, this fails if not run as root. And let's just give it another echo statement here. Let's just say we will try the second step, create a file, and let's say we will create touch. In this case, we will go ahead and give our path, which we just took. Okay, let's just go back. Yep, something like this. Yeah, let's just say test file.txt. So yeah, this still executes. So what we just did is that we are just trying to show the difference between a script which has the implementation of set-e and the one which doesn't. What happens is that even though a specific command fails, in this case we are setting this up for failure, this second command would always run. So if I run this particular script, bash script with the name implies something like if it has set, but yeah, in this case it doesn't have the set-e. Let's just run this. As you can see, this script which does not have set-e would go ahead and try to perform the first step as expected. Since we don't have this particular directory, we basically get an error. But despite that, the second command does go and go ahead and basically create our test file.txt. So this is not a good thing, as this is an unexpected behavior, and we would try to change this with the help of set-e. So let's just say we go back again to our script and make the name appropriate. Let's just set up our set-e. And yeah, so what happens here is this, that if this fails, this secondary bit of command would never be executed. So this command is never executed. So yeah, that's pretty much what set-e does. So let's just try that again. So as you can see, the first command as expected will not run, but the difference here is that the flow of control will not go ahead and execute the secondary statement, and therefore you do not see the second command. So yeah, that's pretty much what set-e does. So yeah, it's kind of a fail-safe. It will prevent your entire code from running in bash, such that it would prevent some unintended side effects, and it's a way of safe proofing your code. And yeah, the next bit is the trap command. While set-e is useful, we also need some custom error handling. That's where the trap command comes in. Let's say we can define certain cleanup actions if the script fails. So the trap command basically allows you to catch these signals and execute some other commands. Commonly it can be used for deleting some temporary files or closing connections, let's say logging your errors, or shutting down some scripts entirely. um, let's say we basically try to implement the trap command such that it listens for error messages. Let's say in this case we'll try to let's say list some let's say non-existent directory, uh, something like that, and if that is failed, the trap would basically execute a cleanup process, and at that point we will just delete some unwanted files. So yeah, let's try that. Let's just clear our workspace. We'll create, let's say, script with trap. Yeah, so in this case, let's say okay, here I would like to create a new directory which basically allows us to do that. Let's see our working directory. We are okay, let's just say mkdir tmp. Okay, let's just do that. Let's okay, wait a minute. Oh yeah, it's there. Okay, it didn't appear on the screen. So yeah, let's just do that. Vi, let's say script with this trap. Go to insert mode. We'll implement our bin bash. Yeah, so here we will write trap echo. Let's say an error has occurred or something. In this case, it's important that you follow the conventions of single and double quotes depending on the command statements that you wish to print out, otherwise the code will not run as intended. So let's say an error has occurred, cleaning up, or some message like this. Let's say something like this, and we will then go ahead and say rm-f, and we will basically give out the whole path for that specific root file. In this case, we will just go ahead and do home slash our entire path. Let's say in the temp file we basically attempt to create a temp file .txt, and yeah, so what will happen is that if the non-existent directory has been found, then it will basically trigger the trap, and we will empty out all the log or whatever information that is going to be stored in that specific temp file. So let's go ahead and do that. So let's just say step 1, and we will say create a temporary file, and let's say touch, and let's go ahead and basically write the whole path. It's a bit annoying, but we don't have a choice, so something like this. Let's just say something like this. Yeah, so we will try to attempt to create this particular file, and let's go with the second statement, where we basically write step 2, running a failed command. So we know that this command will fail because this we are basically trying to trigger the trap. So here we will try something like non-existent directory. We are trying to list out the contents of this so-called directory. This triggers the trap, and we will basically write echo step 3, some message like this, like maybe like let's say command not executed or something. So yeah, so here what we will see is the contents of tmp. Let's just go ahead and just create some random empty, let's say demo.txt or some demo1.txt, some random files. So since this file is since this trap command is bound to fail, we will basically see our secondary command, which is basically clubbed with the trap, which is rm-f, will forcefully remove all the files which were already present. Okay, one more thing I forgot, maybe I made a small mistake in this. Yeah, here you will have to also mention upon the condition that if the error is triggered, we basically empty out the contents of this particular folder, and we basically got this specific code. So yeah, let's just go ahead and try that. Once you hit this, you can see that we basically try to create the directory, and since the non-existent directory doesn't exist, we basically get the error. And as you can see, if we go into temp, or let's just say ls temp, okay, hi guys, today we will try to cover error handling and debugging in bash. This is an in-depth tutorial which will try to give some idea as to how you can implement error handling whenever you're trying to implement automation or certain DevOps tasks, which would be possible with the help of giving you a better understanding about what error codes are and how they influence the reliability of your script. We will also try to work with set-e flags in order to implement an automatic error termination. Also, we will talk about trap, which is another one of those commands which are available within Linux in order to catch and handle errors in a professional manner. So yeah, let's get started. Before we jump right into it, in Linux there is a concept called as exit codes, and we would like to now highlight some of that importance with the context of error codes. Whenever a command is executed in bash, each of these commands usually returns an exit status. Such an exit status is a numerical value which is indicative of whether the command would succeed or fail. For example, whenever you execute a command, it would return an integer exit code, and these codes vary depending on the outcome. If it is 0, it means it has been successfully executed. If it is a non-zero value spanning from 1 to 255, then it is basically indicating a failure in execution. These values are usually captured by a special variable called $? So let's just try to do that. I am basically located within this specific folder. This is my working directory. For the purposes of this demonstration, let's try to create a script which would try to list out the contents of a folder, and we will try to capture its exit code. For the purposes of that, I will create a new directory, mkdir demo. Within demo, I will basically create let's say an empty demo.txt, and let's just try to echo some statement. Into this specific demo.txt, let's just exit out. Yep, and we will clear our workspace. We'll create a new empty script called, let's say, capture.sh. Into this we will implement our bin bash, which is an interpreter from bash into our script. Let's try to basically execute this file of listing out the contents of that specific folder. Let me just change this to lowercase to match the exact name. Here, as I have previously mentioned, the exit code is captured by $question mark, and let's just try to do an execution of this specific file. As you can see, the exit code has been successfully captured. But as you can see, since somehow I have given it the wrong path, because of that reason, our exit code basically did not return a 0 but 2. So here it basically is saying that the list command has failed and that non-zero error code has been returned and has been captured by $question mark. So let's just try to get this right. Let's just say let me just maybe get the right present working. Let's just say path. Let's just go into demo. Just working directory. Okay, let me just copy this entire path and go back. Let me go back again into my script file and just delete a bunch of this and give it the right executable statement. And yeah, let's just try to again run this script. As you can see, our exit code has been returned as 0, which means that the ls command has successfully returned the status of this list, and as you can see, the directory does exist. So yeah, that's how you can capture exit codes. You can basically combine this particular feature by determining whether the specific command has been successfully executed or has resulted in some kind of a failure, implement conditional statements, and we can go ahead and also implement error handling and more. Let's just say we try to implement a script which uses exit codes with some conditional statements. So here we will write check directory, let's say check dir.sh, and we will go into insert mode. We'll write some bin bash, and yeah, so here we will basically try to capture the contents of a directory, and then depending on the condition, if it is true, we will present some message as the directory does exist. Otherwise, if it does not exist, we will basically exit the condition and we will come out of the condition structure that we have set up. So let's say if ls, let's just say for the purpose of the demo, we just give it a non-existent directory, something like this, and if the exit code is 2, we will store that information into this specific empty folder, and then we will print out directory does exist, else we will type echo error, the directory has not been found. So yeah, and we will exit with the help of our custom exit code. So let's say something like this and come out of the condition. And yeah, so this is a basic implementation. So here we were basically evaluating the outcome of the list command, and here this exit code basically is used for suppressing any errors any of such errors would be sent to this specific location, and if this condition is is it successful, depending on that condition, the first echo statement gets printed. Else this secondary statement is printed out with our exit code 1, which will allow us to exit out of this loop. So yeah, let's just say we try this out. In this case, we do know what's expected, and we will see that the error, because the specific directory doesn't exist. But here, if we just try to change this in favor of our previous path, let's just try that. Okay, let's just try that again, but with an existing file, and you can see that the contents have been listed out and we get the first echo statement. So yeah, that was a pretty small demonstration of how you can implement such conditional statements along with exit codes